Welcome to today's show and tell tech webinar. I thank you from wherever you are. I think we had a broad spectrum from around the world. Maybe you're getting coffee or going to bed. But I'm here with Synchro today, the program manager, and also my colleagues Jason Adelars and Shamini Toledo. We are going to help field questions at the end of this. And of course, our panelists, Michelle and Kim and Tom from Sonardyne. I'm going to jump right in, but just a couple of things to mention. You've probably done a million webinars. This Sonardyne team's going to speak for about 15 minutes, and we're going to save all the questions till the end. So pop those in the chat, pop those in Q&A, or right after they finish, and we'll answer those in the last 10-ish minutes. Obviously, if we run out of time, we will get those questions to the team to answer afterwards. If you really need to come off mute to expound upon a question, just let us know. Just in case you haven't been to one of these before, we try to bring folks that have gone through our testing program when they're testing immersion technology or something that's coming out that hasn't been out on the shelves before. We those people that have participated, such as Sonardyne, we offer them a chance to spotlight their tech and talk a little bit about the case studies, so then you can ask questions, and it helps connect, obviously, directly with the developers, but also help them, design a product that meets user needs. So I think without cutting into more time, I will give you Kim and Michelle to present and Tom to answer questions after.
I will share. Let's do this. Can you see that?
Yes.
Yep, lovely. Yeah, thank you, Amy, for that introduction. Hi, everyone. I am Michelle Barnett. I'm Business Development Manager for Ocean Science. So I'm going to be talking specifically about the origin ADCPs that Synchro used. I'm joined by my colleague, Kim Swords, who's our technical sales manager in our Inc. office, and she's going to introduce you to Sonardyne. And we've also got Tom Comerford on the call as well. So he's our ADCP data scientist. So yeah, on the line to answer any kind of heavy technical questions if you've got them at the end there. So handing over to Kim.
Sonardyne's vision, leading the world into making underwater work. What does that really look like? So for Sonardyne's academic and ocean science customers, it looks like this. Michelle, next slide. Working from the right to the left, my customers with the larger vessels, they're fitted with Ranger 2 USBL systems to position subsea targets. So ROVs, remotely operated vehicles, landers that are fitted with scientific instrumentation, manned submersibles like Alvin. USBL, think of it as underwater GPS. You're getting latitude, longitudes, northeast, eastings to your subsea targets. In addition, imagine you're a scientist in your manned submersible and you want to say something to the gentleman at your friend that's on the surface ship. In addition to positioning, we have telemetry capability, modem, and so you can send acoustic comms between the surface ship down and then down to the manned submersible. Sonardyne work with the seabed geodesy community. Those are the guys looking at plate tectonics. They deploy a small number of subsea monuments, which we refer to as fetch, various water depths, shallow 1,500 meters. I've got one folks that put it down at over 6,500 meters. Right now, at the moment, they're putting some down in 600 meters. So those would be our shallowest. Those customers use a USV or unmanned surface vehicle to accurately position their subsea monuments using GPSA operations. I have a small subset group of PIs that aren't particularly interested in the horizontal movement of the plates, but they're very keen on any vertical displacement. So their subsea monuments, the fetches, will be fitted with high accuracy pressure sensors. That data is logged inside the fetch units, and then all of that data can be acoustically harvested. Shows a USV, but realistically, those guys just have ships passing in the area and they'll suck the data up that way. Sonardyne offer a BPR, bottom pressure reference system, which is used in the tsunami detection system. With regards to our Met Ocean, our ocean observing customers. This is the good segue because Michelle can go and talk about our ADCPs.
Thank you very much. Yeah, so I'm going to just dive straight in. I mean, where Sonardyne ADCP journey began actually started quite a time before Origin. So we have something called our Syrinx Doppler velocity log. These come in 400 kilohertz and 600 kilohertz variants, so offering sort of 120 meters and 80 meters profiling range respectively. And very good for kind of you're mounting on a vessel, right, and covering a large area, so you're getting information on currents over that large area. So we've also got our Sprint Nav family, so that's sort of our class-leading hybrid navigator. So that combines INS with that DVL, so it's got the same ADCP capability in these instruments as well. And all of them, they log the industry standard PD0. You can have that log into the device, or you can live stream it. So that's kind of where it started for us with ADCP. Where the journey went next very much was Origin and what they are, they're dedicated ADCPs, whereas sort of before, previously it was kind of like navigation products. These are ADCPs sitting on the seabed. That's where the story began. So why did we do this? So these are seabed ADCPs, right? So traditionally with that kind of instrument, the way you deploy it is you set it up, you put it on the seabed, it's logging for a certain amount of time, and it's only when you recover it can you look at the data, can you confirm the validity of that data, right? So I suppose you can say it probably introduces somewhat uncertainty of what the device is doing while you've not got access to it, right? Did you set it up optimally, or did you even turn it on? I've heard stories like where people have forgotten to turn it on, they've deployed it, and then they come back a month later and they've collected no data. So is that what I put on the side as post-deployment anxiety? And this is very much why Origin was sort of introduced. So in very simple terms, what the Origin ADCP is, it's an ADCP with an integrated acoustic modem. So it's providing you that acoustic link so you can check on your ADCP, and it has onboard data processing as well. So if you're not familiar with the unit, just to give you a very brief rundown. So it's a 625 kilohertz device, so giving you like 60 plus meters profiling range, maximum 4 hertz pinging on all 5 beams, so it's suitable for mean currents, for surface waves, for turbulence. It does log the PD0 industry standard data format, but we do offer high fidelity proprietary data formats as well. Number 2, echo sounder on all beams. And the nice thing about this is you can interleave an echo sounder schedule with an ADCP schedule, so you can look at the sort of the ecological and the hydrodynamics at the same time. It's got an internal rechargeable lithium battery. The idea being behind that is that you can charge it up, so you don't need to take off the end cap, so you're minimizing that risk to electronics of sort of water ingress, maybe if you didn't put the O-ring back, just eliminating that basically with a rechargeable battery. We've got an inbuilt MF modem as well, which I've already mentioned. So that's giving you remote control of the device when it's already sitting on the seabed. It also gives you access to data while it's sitting on the seabed. You don't need to wait to recover it. And the nice thing about these units is they're compatible with our existing sort of topside systems that have modem capability. So our Ranger 2 SBL systems or our Dunkers, you can talk to these devices with these existing systems. Onboard data processing. So what that really means is both, these devices do collect they do log the raw data, but perhaps you're interested in looking at wave metrics. You can have an algorithm on the device that will process the data to then spit out a NEMA style string that will tell you, wave height, maximum wave height, significant wave height, wave period, all of these kind of wave metrics that you would usually only get if you kind of post-process the data later on. So Sonardyne have developed a handful of algorithms catering to sort of typical ADCP use cases. So processing it for currents, processing the data for waves, processing the data for turbulence, processing the data for CARTOD, so quality assurance of real-time oceanographic data, if that's something that you're keen on. So we've got those, but we've got a software development kit as well. So really, if you want to design your own processing algorithm, go for it. The last one, it's the full environmental monitoring system. So I mentioned obviously previously it being compatible with sort of topside modems. but we've got acoustic releases, so you've got an easy way to recover these devices if you need. And then there's a bunch of sort of ancillaries. So we've got external rechargeable batteries. So if you really want to monitor for a long period of time without recovering, we've got that as well. We've got something called an eMux. So that's providing multiplexing capability for third-party sensors. So any sensors that you've got plugged into that will be, all of that data is drawn into the Origin ADCP itself, and it's fused and time-aligned. So you've got all of that in sort of one package. And we do have something called an Origin environmental lander as well, which will house the eMux, it will house batteries, it will house the third-party sensors, and it's also got built-in dual redundant acoustic releases, so you can recover it. So it's just that full environmental package. So for the fun part, I think, so the case studies. So on this slide, it's kind of a small selection of what's been done so far with Origin 600. So the ones turning in purple right now are the ones I'm going to talk about a little bit in more detail, just because they demonstrate sort of usage of different combinations of that feature set that I just described, and kind of how that translated into real world advantage. One thing I would say, if any of these on this screen right now pique your interest, we've got plenty more materials, data, all of this kind of thing. If you want to know more, please do get in touch. Yes. So first one, onboard data processing versus post-processing. So this was a piece of work done by a company called Dynamotion. So they needed current information and they needed wave information because they were doing a tidal energy resource assessment project. So the ADCP on the right is what they typically use. They deploy that, and then they would only get that currents and waves information once they'd recover the device, and they process the data with a post-processing software package. In this particular case, they deployed Origin 600 alongside their typical ADCP, and that was processing the data for currents and waves while it was still sitting on the seabed. Once it was recovered, they didn't need that extra step of post-processing. And this is the data they got from it. So the right-hand side, what you can see here, this is currents information. So you've got current speed on the top, current bearing on the bottom, time along the x-axis. The purple is Origin processing on the device itself, and the orange is the reference system. So you can see very good agreement. In fact, there's further statistical analysis that's been written into a paper. There was no significant difference. The R-squared was very close to 1. It was, very, very good agreement. And similarly, you see the same for waves. So this is significant wave height on the top and maximum wave height on the bottom, just as a snippet of sort of the wave information you get from the devices. But again, you can see very good agreement. So it's giving that advantage of not having to post-process after the fact. Next case study, so real-time reporting of currents and waves for testing and proving grounds. So we've actually had a couple of cases of this, but I'm going to focus on, so this one, which is the Smart Sound Connect subsurface. So this is an initiative led by the University of Plymouth and Plymouth Marine Laboratory. So Sonardyne actually provided an entire communications and navigation network that facilitated this testing and proving ground, right? But the one thing that they did need was real-time reporting of these key subsurface parameters, so currents, waves, temperature, everything that Origin could do, because it was for operational safety purposes. When is it safe to put the AUVs on, or when is it optimal to put the AUVs in for testing? And you had that real-time element because you had Origin sitting in the lander on the seabed, but it was connected to PML's L4 scientific buoy with one of our Ranger 2 USBL transceiver heads. So you had that communications link, and you can see that data now. It's available on the Western Channel Observatory website. And when I set these slides up, I literally went to the website, took a screen grab, and that is exactly what you're seeing on the right-hand side. So you can see this is just current speed, but that's just been pulled up with the ADCP sitting on the seabed in Plymouth. Next one, so hydrodynamic and ecological assessment at a wind farm. This was a piece of work done by the University of Highlands and Islands, the University of Aberdeen, for the EcoWind project. So this is quite nice because it kind of really shows that triple whammy of currents, waves, but also echo sounder in this case, because they needed that hydrodynamic and they needed that ecological assessment at the same time, so they didn't have to put down separate instruments, and that's why they opted for Origin 600. So I put some of the example data that they got from the deployment, so you can see sort of speed, bearing of the currents and the wave height as well on the left-hand side. But I'd put a couple of examples of the echogram. So what the echo sounder capability of the instrument was doing. So you can see on the left, there's the vertical water motion. You've got a diving bird signature. This one on the bottom is, I think, my favorite. But you can see a school of fish interacting with a scattering layer. So you might assume that's like a plankton layer, right? And all of this could be calibrated as well so that you could get actual biomass data, you could get quantitative data. It wasn't just qualitative data. From this project as well, an onboard fish detection capability has been developed. So it's what I was talking about, having an algorithm that you can design what suits your application, right? So this algorithm here now will basically process the data on the device, and it can spit out over the acoustic modem current information and then a lot of information on what's going on with fish. So the number of fish detected, average area of fish, etc. You can see it in those numbers there that I've put on the screen. So the last case study, so this is multi-sensor integration for comprehensive environmental monitoring. So I've obviously talked about this a little bit earlier on, but this was kind of really demonstrating the facts. We did some work with Planet Ocean, so they provided the third-party sensors, and you can see them all integrated here with the eMarks, and then that went into the lander. But you've got a Seabird CTD, you've got a Chelsea Technologies turbidity sensor, you've got a 4H Jenner CO2 sensor, and a Sequoia particle sensor, and all of these were in the lander. It had an acoustic link to the Marina PC, and then you could display the data sort of live in this web portal. And again, I just took a snippet of the web portal when this project was kind of going on. This is exactly what you were seeing. Again, there's the Origin in its lander collecting data on the seabed, and you could see information not only coming from the ADCP, but the sensors that had been fused with it as well. So last couple of slides, why we're here, right? So Origin 600 and Synchro, it very much is the Origin story continues here. So a massive thank you again to the Synchro team, and they put the Origin 600 ADCP through its paces, and again in a very different way. So the objective of the guys here was very much twofold. So firstly, to resolve the vertical structure of currents associated with internal waves in Monterey Canyon, and to identify correlations with biogeochemical parameters. And then because you could do the waves at the same time, they were measuring characteristics of the surface wave environment to evaluate the operational nearshore wave models and assess their utility in sediment transport applications. I do encourage you to read the report. I'm not biased at all, but there's some really interesting findings in there. And the one I'm going to just leave you with today that I think is one of the most sort of like, maybe I could say most significant ones, is this one here. So what you can see here is wave information coming from the ADCP. That's in blue. So you've got wave height, average period, average direction. But what you're seeing being overlaid is in orange is wave data that was coming from an output at 20 meters depth from the nearest transect in the modeling and prediction system operational nearshore wave model, which is distributed by the Coastal Data Information Program. So you can see the blue and orange, right? There's very good agreement. And I think the nice thing about this is it's basically saying that the wave model is reproducing those wave metrics as was actually observed with an ADCP. And given that it's capturing that wave field really well, it supports its application in sorry, it's a lot of information. It supports its application in sort of like erosion process studies in the nearshore region in the head of Monterey Canyon. So I'm going to leave you with that, and that's the end of my presentation. But yeah, questions? I'm going to stop sharing.
Thank you so much, Michelle and Kim. I love that we could see an echosounder image that actually looked like the animal itself. I will pass everything over to Shamini and Jason.
Yeah, that was great. Thank you, Michelle. We're gonna put up a quick polling question while we do a few minutes of Q&A. I see a couple of questions in the chat already, but I kind of wanted to share that, like, really struck me about this system was, so in our domain, like we do a lot of ecosystem monitoring and try to look at everything everywhere all at once and as quickly as possible. That's what marine managers want. They want more data, as soon as possible. And what was great about this is being able to kind of take the different sampling modes. And so you got physical and biological on one unit with the ability to expand to different biogeochemical systems, and then having that acoustic modem to be able to get that data, sooner rather than having to lift the entire system off the seafloor to be able to download. Fantastic. And so I'm wondering real quick, can you talk about like what is the preferred domain that the system deployed in? Is that the 600 in Origin 600 is the depth? Is that the depth rating correct?
So the 600 refers to the frequency, so 625 kilohertz.
Mhm.
So it's, in terms of depth rating, it's actually 150 meter depth rated, but gives like 60 plus meters of profile. So
Okay.
yeah.
So 150 meters depth. So we're talking about like near coastal physical monitoring with some biological. Great. Yeah. So what would be like some preferred like use cases for this or how have people kind of been using this so far as customers go?
So I think that's what I was trying to demonstrate with the case study. Sort of all of these people have been using ADCPs for a while, and just by combining what you've mentioned there, just these kind of there's multiple features, that it's not just an ADCP, right? And it's given them that advantage. So we've had customers that do work in the renewable space, right? So there's guys actually, like you said, that they need to combine the ecological and the hydrodynamic. Maybe they don't need that real-time element, but they're able to do that. They don't need to buy two separate instruments. And obviously, when it's been collected on one instrument, you don't have the confusion of kind of trying to match up two data sets, right? And then, like, on the other hand, sort of people working in the renewable space, having that, as I understand it, because I'm ocean science, right? As I understand it, a lot of contractors, for instance, they are paid for the data that they provide to the end user, right? Not on the time that they spent doing it. So having that assurance that they can actually check, oh no, I have turned it on and it is running the schedule that I want. But also the fact that it's processed the data, they don't have to spend that time later on using a post-processing package. This is where they've been sort of applying it. And then, yeah, very much in the ocean science space, it's kind of that real-time element that's I've seen come to the forefront in the ocean science space with people doing like the testing and proving grounds. They need that information to be able to kind of make informed decisions, and not otherwise it's kind of the information is after the fact is not actually as usual if in kind of testing and proving grounds. Hopefully that answers your question.
Yeah. Great, thank you. Yeah. All right, I'm gonna go. I've got a couple of questions here. First one is like a technical question of what beam does the echo sounder operate on?
It's all 5 beams.
And can the unit be ordered without the acoustic modem feature, or is that fully baked in?
No, yeah, it's built in. It's part of it. It's just that is what Origin is. Yeah.
Okay. And another question is how has it been working with Synchro? How did you find that?
I like that question. I mean, you guys were great. I mean, I think working with Synchro, it allowed us to kind of dig into more of I mean, like we've just described, I think usually sort of the user or the end user, the customer uses it. And yes, we can see this great data and we can hear their feedback and why it's provided them benefits, but not really seeing how specifically they've used it. I don't know what schedule they've used and how it's worked, like operationally, how it's been beneficial. With you guys, obviously, we're kind of there with well, I wasn't personally, like understanding what you were doing and like what your application was, and how we could test the capability of the instrument based on all these different things that you wanted to find. So I think and I've said this before, I think it puts the unit through its paces more than just like a typical user just in a specific or niche application, for instance. That's why I kind of really loved working with Synchro.
Great. Appreciate that. Another question is what frequency is the ADCP operating at?
625 kilohertz.
625 hertz. Let's see.
Sorry, that was the modem in the question, right? Not the carrier frequency.
Oh, for the acoustic modem, yeah.
So which is what is it, 20 to 34 kilohertz? Is that right, Michelle?
Yep.
I'm curious about the eMux, and particularly like the interfaces for it. Are for like the third-party sensors, are those like analog or serial or Ethernet or how are those ports kind of set up?
I'm gonna let Tom answer because he's here for.
It's a little outside of my wheelhouse even, but I think it's yeah, so they're all serial sensors. They support RS-232 and RS-485 connections to the sensors.
Okay. Cool. Got another question here in the chat. Are you able to break down what industries are primarily interested in the Origin 600?
I think it's initially there was that more interest from the ocean, I guess, from the ocean science side because of the customizability of the unit. I mean, I mentioned having this software development kit, right? So if you can design your own processing algorithm, then I guess kind of like the world's your oyster in a way. You can kind of you know what you need to, you know what kind of data you want, and that allowed those folk to kind of do that. But very much we've seen and we've had customers from across markets. So I mentioned like renewables, but again, it's depending on what they're trying to achieve. There's interest in different elements of the unit, whether it be that real time reporting element or whether it's bringing in like the third party sensors, so they can actually monitor everything with one package as opposed to having lots of different things. But yeah, like energy and like a carbon capture storage as well. So we've got monitoring landers so people working on carbon capture storage, they have a requirement to do monitoring, measurement and verification, right? So the ADCP is built into these landers because, you know, if they saw a CO2 leak and you understood what was going on with the currents, that kind of thing. So it's very broad where it's been applied.
Yeah, I can definitely see how, you know, if an industry is putting a lot of infrastructure in the water, so offshore wind, offshore wave energy, current energy, you know, aquaculture, you want to kind of understand how that infrastructure is interacting with already the physical dynamics, and then how the biological is kind of also interacting with that. A lot of questions there. We in our area we're trying to figure out floating offshore wind is kind of coming to California, and so we're trying to like sort out how do we monitor things 30 miles offshore and in 1,500 meters of water, and it's a major infrastructure project.
That is something that it's funny you say that. It's something that, or again, Origin's been linked to already. So it was one of the case studies I had up on the screen, but it was that dynamic cable monitoring that they needed to do because, you know, they want to understand how long that cable is going to last. So they wanted an ADCP with that real-time element, so they could make, you know, they could have that information. Would it inform them to for like increase their service intervals, all that kind of thing? What's going on with those dynamic cables? So they had that just real-time link. So again, it's lent it to that itself to that as well.
Yeah, I'm curious. You know, a lot of the case studies you talked about, it was mounted on the bottom. Curious if it can be configured to be on a float looking downward. Obviously, you won't have the waves, but is that feasible?
And not right now. It is very much in something that we're working on developing. So we're working with partners already because recognize that, you know, people want that flexibility, right? If you buy an ADCP, you want to mount it in whatever configuration suits your application at any given time. So yes, it's coming.
Great. Well, I think we're at time. And yeah, I'll pass this back over to Amy if you want to close us out.
Yeah, thank you. I was just going to say perfect timing. I do you want to acknowledge Davey's question in there? We didn't quite ask it, but it was more about the steps of how engaging with Synchro. We can send that out later to our attendees, but I appreciate the Michelle and Kim and Tom being here as well as my colleagues, and I hope you learned something. I did. Thanks, everyone.
Thank you.
Bye.